Today we're going to talk about problem solving with the discriminant and with the quadratic formula. Okay? Before we can get started on this page, we really need to remember what the discriminant is so that we can have an intelligent conversation about it. Okay? Can anybody tell me what the discriminant is? Anybody have any idea where to look? Oh, maybe you could look in your notes? Okay. What is the discriminant? B squared minus 4AC. Okay? B squared minus 4AC is the discriminant. Okay? So, there is a hint at the top of the page. We're going to need to use that for sure. The vertical motion formula is D equals RT minus 5T squared, where R is meters per second and D is meters and T is seconds. Got it? When we talk about distance, I need to make sure you understand that we are talking about vertical distance. Another way to say that is distance above the ground, right? Distance from where you started, I guess I should say even. Okay? So let's start with number 2. Number 1 is cool. I have a story for you about that, so we're going to come back to it in a moment. Okay? Number 2, a flea on the floor wishes to jump on a dog's back. Now, I think this is funny personally because I got this from a worksheet that talks about real-world problems. Is anyone in here going to be measuring how fleas jump anytime soon? Okay, well, so you don't have to now because you got it, right? You already know how to do it. Okay, a flea on the floor wishes to jump up on a dog's back, which is 0.9 meters above. The flea can jump with an initial upward velocity of 4.3 meters per second. Can the flea jump as high as the dog's back? Please understand, we are not asking, can the flea jump on the dog's back? What's the difference from what I said and what the question is on the paper? It's just, can it jump as high as the dog? It's not saying, I don't know about the flea's aim, right? I've never spoken to a flea before, so I don't know how well it can jump or if it has a hard time jumping or anything like that. Okay? So this is just saying, can it jump as high as the dog's back? If it had good aim, can it jump on the dog? But we're not talking about the aim. Fair enough? Okay. So we've got to figure out where everything goes, and we are going to be using the vertical motion formula at the top of your paper. So what information does it give us in the sentences that will help us fill out the formula at the top of the page? So 0.9 meters, what is that? That's the vertical distance, right? So 0.9 meters equals RT minus 5T squared. What is R? Meters per second. Do you know anything about meters per second in this problem? 4.3 T minus 5T squared. Okay? What do I do? Get it equal to 0, right? I want to get it equal to 0. So let's subtract 0.9. 0 equals, do you mind if I put it in standard form while we're here? Now, if I'm doing this problem, if I am problem solving with the discriminant, am I doing the whole quadratic formula? Or am I just doing the discriminant? Okay, I am just doing the discriminant, right? Even if I'm just doing the discriminant, I still need to know A, B, and C. Yeah, A is -5. B is 4.3. C is -0.9. Okay? So 4.3 squared, b squared, minus 4 times negative 5 times negative 0.9. Yep. Oh, thank you. Good catch. I just got T crazy, I guess. Sorry about that. Oh, okay, sorry. 4.3 squared minus 4 times negative 5 times negative 0.9. That's what I got. Did you get that same thing? 0.49. So the question that I'm supposed to answer is, can the flea jump as high as the dog's back? What is 0.49 telling me? This is what it's telling me. If I have a parabola, we're going to pretend it looks something like this, because that kind of makes sense, right? If a flea jumps up and then he's going to come back down, right? And I know the dog's back is 0.9 off the ground, 0.9 meters off the ground. What is 0.49? 0.49 is the solution, or the point of intersection. So here's the path of, well, not the path of the flea, but here's the distance off the ground versus the time that the flea jumps. Here's the height that we're trying to get the flea to get to. My question is, does the flea get that high? Twice, right? How do you know by looking at this number that it gets there twice? If you do the discriminant, we had a big table the other day we looked at, where if it was positive and a square, then it was 2 rational roots. If it was positive and not a square, it was 2 irrational roots. If it was 0, there was 1 double root. And if it was negative, it was 2 complex roots, right? Do you remember that? Does anybody have that table with them? Look at it. It's on the worksheet called Solving Quadratics with the Formula. Does anybody have that? Solving quadratics with the formula. Something close to that. Let me see it real fast. Okay. Thank you, Michael. So here it is right here. You remember this table that we looked at? If it was 0, there was 1 rational root, 1 rational double root, excuse me. If it was positive but a perfect square, there's 2 rational roots. If it's positive and not a square, it's 2 irrational roots. And if it's negative, there's 2 complex roots. So here's a practical application of this silly chart that we had to work with for a couple days. What kind of number did we get when we found our discriminant? It's positive, and it's a squared. Do you know that? What's the square root of 49? 7. So what's the square root of 0.49? 0.7. Okay? So it's a positive and a square, so it's 2 rational roots. If we solve the quadratic formula, I would find 2 places where it crossed. Here and here. Okay? So when it says, can the flea jump as high as the dog's back? When this number is a positive number, then my answer is yes. It can actually get as high enough 2 different times to possibly jump on the dog's back. As long as that number checks out to be positive, we're good. What if it's 0? What if it's 0? What would the graph look like? Did you just say, what if the dog is sideways? Maybe. Remember, I'm not talking about the aim of the flea. I'm saying, could the flea get high enough? What if it's 0, guys? What would it look like? Like that. Can the flea get high enough to jump on the dog's back here? Yes, but only one time, right? It only has one chance. Okay? What would it look like if it was negative? We're trying to get to a certain height, and here's the parabola. Right? It doesn't get there. Fair enough? So let's talk about basketball. Anybody like basketball? No? Okay, sorry. We're going to talk about it anyway. In order to dunk a basketball, Jim Shorts must jump 1.2 meters above the floor. He can... I didn't make up the name. It just came in the problem. He can jump with an initial upward velocity of 5.1 meters per second. Can Jim dunk the ball? Hey, Victoria, they're laughing because Jim, like J-I-M, you can also say gym like you're playing in the gym. So like that kind of Jim Shorts. That's why they're laughing. Okay? You got it when I explained it to the person not from the United States. Okay, so let's start with an equation. What can I put in my equation? What do I know? Do I know a distance? I know 1.2 meters is the distance off the ground. How high is that?
1.2 meters.
Is that as high as a basketball goal is? It's not? Huh. You're right, it's not, is it? Okay, so this is clearly a fake. No. No, his feet. Yeah. This is real-ish. I mean, hopefully nobody's named Jim Shorts. But for the record, there was a girl that my mom grew up with. Her name was Crystal Lear. That doesn't sound bad, right? Her middle name was Shanda. Yeah. Don't tell it. But she's sweet. D equals RT minus 5t squared. I got my D. Okay. I got the distance off the ground. What about RT? Do I know an R? Okay. So 5.1 t minus 5t squared. So what do I want to do? Equal it to 0 minus 1.2. So I get 0 equals negative 5t squared plus 5.1t minus 1.2. And I'm not going to put a t there this time because I wasn't supposed to last time. Hey, last week when we were solving stuff equal to 0, and by last week I mean a couple days ago, we moved everything so that our t squared term was positive. Why aren't we doing that now? Does it matter? When we're factoring, it really does matter. Okay, but if we're doing the quadratic formula, it does not. Okay? So what is my A? B? 5.1, good. And C? Negative 1.2. Excuse me. So I have B squared minus 4 times A times C. I just don't want to confuse anybody, so I just go ahead and put that squared term in for parentheses. You don't have to do it in the calculator unless it's a negative term. So that's what I got. 2.01. Does the 2.01 tell me anything about the problem? Not the number, but the fact that it is positive tells me he can do it. Yes. I don't know about Jim's skills. I don't know if he is able to. I know he can jump high enough to be able to. Fair enough? God bless you. Look at number 1. A friend of mine tells a story about a pilot who was flying an aircraft who was dropping bombs on the enemy. That was his job. That's what he was supposed to do. But he was pretty experienced. He'd been doing it for a while. But one of the people that was in the plane that evening was very new. Very new officer flying for the first time, dropping bombs for the first time. And they dropped a bomb, and they started to fly off. And they could see the anti-aircraft guns on the ground shooting at them. And this brand new kid was freaking out. Right? Wouldn't you be freaking out if you were in a plane and you could tell people were shooting at you? Okay? And the pilot was just not stressed out at all. He's just flying casual. Right? And he's like, how can you be so calm at a time like this? And the pilot says, because I know how high we're flying. Because he has the altimeter right there. And he knew what kind of anti-aircraft guns were on the ground. And he knew, because he was good at math, that the initial upward velocity of those anti-aircraft guns were not strong enough to hit him where he was flying in the air. Doesn't matter the aim of the people on the ground. They couldn't do anything to shoot the bullets or the rockets high enough to hit the plane. Okay? So let's talk about this problem. Target plane flies at 2100 meters. An anti-aircraft gun fires a projectile with an initial upward velocity of 200 meters per second. Will the projectile ever reach the altitude of the target plane? What's going in the equation? Anybody? Where's 200 going to go? 200 is going to be R because it's initial upward velocity, right? That's our R value. So what is going to be our D value? 2100 equals 200t minus 5t squared. So we... Oh, set it to 0. Excellent. Good job, Kirsten. Subtract 2100 from both sides. 0 equals negative 5t squared plus 200t minus 2100. A, B, and C? Okay, wait. This crazy kid earlier said you have to factor out a greatest common factor first. You could if you wanted to. We're letting our calculator do the work. It doesn't care what size the numbers are unless they get too ginormous. A couple billions? Okay. So we have 200 squared minus 4 times negative 5 times negative 2100. That's what I got. What does that say? What does it say? That says negative 2000. Will the projectile ever reach the altitude of the target plane? No. Why? It's negative. No, it will not. On this side, please circle number 5. Look at the other side. So some of you didn't like talking about basketball. How about football? Okay. Now, here's what I need to say about this. It fits for both the basketball problem and the football problem. I know that when you guys are on the field or on the court, you are not thinking about the math. You're thinking about, I better get that block so George can run behind me and go score a touchdown. Or I better get this block so quarterback has time to throw Christian the ball who can go score a touchdown. Or this kid, I don't want you to break people's knees. Yeah, it's illegal. Oh, not on the football field? Okay, sorry. So let's talk about when the football is kicked. Okay? Football kicked into the air with an initial upward velocity of 25 meters per second. So we need to pause for a second. I know there's 4 questions after that, but we need to get an equation set up to use for this problem. Okay? What equation are we going to use for this problem? So D equals what? Do I know R? 25. R is the initial upward velocity, right? And I know that's 25. 25t minus 5t squared. Okay? So now that we have a formula to work with, wait, are we going to use this same formula for number 2 and number 3 and number 4? Probably not, right? Unless it happens to have the exact same initial upward velocity. Okay? For the record, they don't. Okay? So, letter A says calculate its height after 2 seconds. How high is the football after 2 seconds? How do we figure that out? How do we figure it out? We can plug it into the equation. 2 seconds is standing for what? Let me say that again. What variable is standing for 2 seconds? The t, right? It says here at the time, reminding you that t is seconds. So I could say 25 times 2 minus 5 times 2 squared. Well, 25 times 2 is 50. Let's see. 2 squared is 4. 4 times 5 is 20. What's 50 minus 5? Let me say that again. 50 minus 20. 30. 30 what? Meters. Okay. No, not per second. Just meters. It's okay. Calculate its height after 3 seconds. Is that a pretty similar problem? 25 times 3 minus 5 times 3 squared. Keep going. You're talking through it well. What's 3 squared? 3 squared is 75. 3 squared is 9 times 5. 45. So what is 75 minus 45? 30 meters? Okay, so we clearly did something wrong, didn't we? So a football, you kick a football, and then it stays above the ground, 30 meters above the ground, and then it comes down?
Oh, yeah, you got that. Because the ball actually stops when it gets to the top.
The ball stops in the air, so it goes like this, and then stops
Stop at the top.
and hangs for 1 second. It stays completely still in the air for 1 second, and then it comes down?
Yes.
It pauses for 1 second at the top.
Yes. It does. Kick it, he goes. Whee! It really does.
Do you guys, honestly think that a football stops and stays still in the air for 1 second?
Not 1 second, but it does for like.
This says it stays for 1 second. The math, that's not what the math says. The math says if you kick a football, and we're talking about distance over, this is time and this is distance, it goes like this. It's at 30 meters here and here.
That's what I said the first time. You didn't listen.
I was more interested in seeing if people really thought football stayed in the air for 1 second. And apparently they do. Okay? Now, keep in mind if this is time and this is distance, it's not changing a whole lot of distance in this amount of time, but it's not stopping for 1 second, just so you know. Okay? Are we clear about that? Okay. When will it be 20 meters above the ground? How do you figure out when it's going to be 20 meters above the ground? We substitute 20 in for D. That's exactly right. Okay? So 20 equals 25t minus 5t squared. Now, there's not enough room on that paper for me to work this out. So I'm just going to have another little sheet of paper up there that I work it out on. Okay. So if I subtract 20 from both sides, I get 0 equals negative 5t squared plus 25t minus 20. We okay so far? How do I solve this for t? I have to have a, b, and c because I'm going to solve it using what? Quadratic formula. Okay, good. A is negative 5, b is 25, c is negative 20. So this crazy kid earlier said, we cannot use the quadratic formula to solve for t because the quadratic formula starts out x equals. So this time it's t equals, right? We're solving for the variable in the quadratic. Are you okay with that? X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay so far? Word. X equals negative 25 plus or minus the square root of, and I'm going to let my calculator do the math for me. 25 squared minus 4 times negative 5 times negative 20. 225 over negative 10. What is the square root of 225? Do you know that? It's 15. So I have x equals negative 25 plus or minus 15 over negative 10. Okay. What is negative 25 plus 15? Negative 10 divided by negative 10. 1. What is negative 25 minus 15? Negative 40 divided by negative 10? 4. So what's the answer to the question? When will it be 20 meters above the ground? 1 and 4 what? 1 and 4 seconds. Okay. Now, when will the ball hit the ground? How do we figure that out? What do you mean? What do you mean? When d is 0, right? So 0 equals, what is it? 25t minus 5t squared. Can I go ahead and write it like this? Negative 5t squared plus 25t. In this problem, what is a, b, and c? What's a? Negative 5. What's b? 25. What's c? 0, right? There's not a number here. I can't just put one in there just because I like that number. I have to put a 0. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Guys, what happens right here? Is it? 4 times negative 5 times 0 is 0, isn't it? So I have the square root of 25 squared. What is the square root of 25 squared? The square root of 25 squared is 25. X equals negative 25 plus or minus 25 over negative 10. What is negative 25 plus 25? 0 divided by negative 10? 0. Negative 25 minus 25? Negative 50 divided by negative 10? 5. Which one answers my question? When will the ball hit the ground? The ball started at 0. It's going to hit the ground at 5 seconds. I know you did, but it doesn't do any good to answer it if you can't prove it. Circle 2 and 3. And on this other page that I gave you, circle number 2. We did a problem like that on last night's homework. There is one like this on your test on Monday. Your study notes are on the board. I know right now it says pre-AP, but it's the same study notes. You have a test Monday. Study session after school today. Study session before school Monday. I will send out reminds to help you remember. Okay? Any questions? Have a nice day. Peace.